Good morning, friends. Today we are going to discuss about the chapter the laser. It comes under the module 4. To begin with, what exactly the laser is? So, laser it is acronym means it is a short form stands for light amplification by stimulated emission of radiation. So, what exactly the light amplification by stimulated emission of radiation? So, we'll come to know in due course. So, laser is a device which is used to amplify the light radiation. Here, the light radiations are going to amplify, they are going to multiply. That is the beauty of the laser. Now comes the measure, that is, instead of the light amplification, we use the word microwave amplification by stimulated emission of radiation. So, based on this, the measure, the laser was devised. That's why we can call the laser is the outgrowth of this measure. Now let us come to the brief history. Okay, how exactly the laser was developed. In the 1954, the Charlestown and Arthur Shallow of the Bell Laboratories, they proposed the theoretical concept for the laser. First, the theoretical concept was developed. Next, in the year 1960, the first working solid state laser called the Ruby laser was developed by Maiman. So, in the year 1960, the first laser was developed, working laser was developed. Next, the very next year, in the 1961, the first gas laser was developed called as the helium neon laser. It was developed by Ali Jawan and his co-workers. Next year, that in 1962, the first semiconductor laser was developed by R.N. Hall and his co-workers. Since then, many more, the thousands of lasers they have been developed till today. They have a wide scientific scope, the applications are there. That's why the laser has been mainly used in scientific, the military applications, medical, and moreover nowadays in the communication we are using this one. Now coming to the laser, what's so speciality about the laser? Okay, what means how exactly it differs from the ordinary light? That also we will see in the next slide. Before that one, what exactly the properties of the laser we'll try to understand. The very important property of the laser is it's a monochromatic source. That's why I use the word highly monochromatic. Even sometimes we call it as a single wavelength. Okay, normally we use the word wavelength, or sometimes we can call it as a single. It has got a unique frequency. It has only one color. In ordinary language, if you use, we can say it has only one color. The next one is the very important property of the laser is coherence. This makes a difference with the ordinary and the other sources. What exactly the coherence? It means whatever the light which is emitting out of the laser source, all the photons which are coming out, they are all in same phase of vibration. It means the photons, the light which is coming out, all they are in same phase of the vibrations. So that makes a special characteristics as far as the laser is concerned. Next concern the directionality. So the directionality of the laser is such a way that even we can focus on the surface of the moon. Okay, such high directionality we are going to achieve in the laser. Along with that one, the one more important property is intensity. It is highly intensive. Okay, so such a the laser is the intensive source that even we can drill the hole inside the metal. Okay, so these are many more such properties are there. So these are some unique properties which are of interest. Next, we'll get into the, as I told, the how exactly it differs from the ordinary light. First, already we have discussed the left side, what are the properties of the laser. Same thing we are going to discuss with the ordinary light. The first one is it's a monochromatic. It means only one color, one frequency or one wavelength, what we have discussed. Here the ordinary light is polychromatic. Means if you take the sunlight, the tube light or incandescent light, we see that there are more than one wavelength, more than one color exists. That's why the ordinary light we call them as polychromatic. Next here second one is coherence, that is it's a coherent source, while the ordinary light is incoherent. It means the light or the photons which are coming out, all they are not in phase. Third one is less divergence, though directionality is very high, the divergence is very minimum, but compared to the ordinary light, they are very highly divergent. If you take the torch and if you try to focus, we can see the divergence and we cannot focus more than few maximum 100 meters also. Here the fourth property is highly intensive, and the ordinary source comparatively it is less intensive. So this is the main difference between the laser and the ordinary light. Now before getting into the what exactly the laser is there, better we try to understand the principle which is involved here. That is, we are studying this in the interaction of radiation with the matter. We know that the matter exists in three forms: solid, liquid and gaseous. The basic constituents are the atoms or the molecules. Now how exactly the interaction of the radiation with matter takes place? The basic principle we try to understand. Here we can observe that we observe that there are many more energy levels are associated with the matter. Let us consider the basic things. Let us consider there are two energy levels, E1 and E2. So E1 we consider the ground state or the lower energy, while the E2 the higher energy or the upper energy state. Now usually the natural tendency of the electrons or the atom is that they want to occupy the lowest possible energy. That's why we see that more number of the atoms, they are going to be in the ground state. They prefer to be in the ground state. Now to begin with that one, let us also suppose that there is one atom which is in the ground state, that we can show it here. So right now this is in the ground state. Now when a photon of suitable energy, we know that E is equal to h nu. Now when a photon of appropriate energy, it is incident on this atom, then that photon gains that particular energy. That energy is E2 minus E1. That's why E photon is equal to E2 minus E1, that is equal to h nu. When it absorbs that particular suitable energy, the photon is incident on the atom. So this atom gains the energy and go to the higher energy state. So this process we are going to call it as absorption. So likewise it goes to the higher energy state. Now the atom goes to the higher energy state E2. Now in the second case, it is in the higher energy state. The atom, as it is shown here, it is already in the higher energy state. Now within a few the seconds, it transits from higher energy state to the lower energy, that is from E2 to E1, by giving out a photon of appropriate energy h nu. Likewise in the absorption and the emission, we can see that the energy of appropriate energy is absorbed, that is equal to h nu. It goes to higher energy state, and in the emission, during its transition from E2 to E1, it gives out appropriate energy of photon h nu. This is absorption as well as the absorption emission process. Now coming to the interaction of radiation with matter. So there are in three ways the interaction of radiation with matter takes place. The first one is known to be the induced absorption. The second one is the spontaneous emission, and the third one is stimulated emission. So one by one we will try to understand what these processes are. To begin with the induced absorption, the same process what we discussed in the previous slide. The atoms it want to attain the lowest possible energy, that is in E1. Now when a photon of appropriate energy E photon is equal to E2 minus E1, that is equal to h nu. When a suitable energy is incident on the atom, then what happens? It gains the energy, and here that is before absorption, and in the second case we can observe that it will absorb the energy and go to the higher energy state. Here it is mentioned as atom star. So this star particularly indicates that the atom is in a excited state of energy, that is higher energy state. So just have a differentiation between the which is the atom is in ground state with respect to the atom in the higher energy state. So in simple words, so we can observe that when a photon of appropriate energy is incident on the atom which is in ground state, it gains the energy and go to the higher energy state. So this a simple process we are going to call it as induced absorption, and it's a natural the phenomena which takes place all the time. So how exactly we are going to define it? When a photon of suitable energy is incident on atom in lower energy state, it gains the energy and it goes to the higher energy state. Simple this process we call it as the induced absorption. So in the induced absorption we can just observe here the process can be summarized here with respect to this, that is atom plus the external the photon, it results to atom star. That atom star it indicates it is in a higher energy state. So this is known to be the induced absorption. Next one, spontaneous emission. Once again, spontaneous emission, it is also a natural process, so which can be analyzed with this particular the energy level diagram. Here the first one, it is before the absorption. So before the absorption we can see all that already the atom is in a higher energy state, it is atom star, it is in a higher energy state. Then what happens? The transition takes from higher energy to the lower energy, that atom transit from higher to lower energy state and it comes to the ground state. During this process it gives out a photon of appropriate energy h nu. So this the process we are going to call it as spontaneous emission. So the definition we can give here, when an atom in higher energy state comes to the ground state by giving out a suitable energy is known as spontaneous emission. It means already it is in higher energy state, within a fraction of time it comes to the ground state by giving out a appropriate photon of energy h nu. So this process we are going to call it as spontaneous emission. Once again this is a natural process. The important time the thing is that the lifetime of atom in excited state is around 10 to the power minus 8 seconds. It means the atoms whenever it goes to the higher energy state E2 or any higher energy state, it stays for a very short interval of time of the order of 10 to the power minus 8 seconds. So within 10 to the power minus 8 seconds it comes back to its ground state by giving out the appropriate energy h nu. The third one is stimulated emission. So coming to the stimulated emission, so we can see that already the atom is in a higher energy state. it is in a higher energy state. Now the atom which is in higher energy state, so if during that time, if a photon of appropriate energy, external photon, if the external photon of energy h nu is incident on the atom which is in higher energy state, what happens? This external photon, it triggers that atom to come down to the lower energy state. During this process, we observe that there are two photons, they are coming out. This is called a photon 1. So this photon 1 we can consider it is the photon which is emitted during the transition from E2 to E1. Whenever it jumps from E2 to E1, one photon is coming out, and the second photon which is, we can call okay, so this is the incident photon. So what happens? So during this process there are two photons are there. The incident photon of same, okay, the frequency it will come out, and the difference of the energy E2 minus E1, that is equal to h nu. So totally there are two photons which are coming out during the stimulated emission, and these two photons, they have same energy, E is equal to h nu, okay, they are in phase, that is they are coherence, and they move in same direction. That's why we can say, so two photons, they are having energy h nu plus h nu. So totally 2 h nu means two photons are emitted during this stimulated emission. So the definition we can go through here. When a photon of suitable energy is incident on atom in higher energy state, it comes to the ground state by giving two photons. So this process we call it as stimulated emission. We stimulate externally, we trigger that particular atom which is in excited state to come to the ground state. So during this de-excitation process, so two photons are emitted. One, the incident photon as it is comes out, and one more during the transition from higher to lower, one more photon. So totally two photons are coming out this process. So this process can be analyzed in this manner, that is the photon plus interaction with atom star which is in higher energy state, we get the atom which will come to the ground state plus two photons. So this is, so during this particular the transition, the stimulated emission, from one photon we get two photons. And the important thing what we have to remember is, so this process takes place within 10 to the power minus 8 second. So within the 10 to the power minus 8 second, this process we have to complete. Otherwise what happens? It will be a spontaneous emission. On of its own, the atom from higher energy to the lower energy, it will come out and it will lead to the spontaneous emission. So to achieve the stimulated emission, we require that it should be less than 10 to the power minus 8 seconds, such that we can assume the stimulated emission.